Hello everyone, I am the Unity Dude, and in this tutorial I will teach you how to create dynamic holes for your Unity game. The final result will be a hole in your mesh, which you can move and resize at runtime. For this tutorial, we will be using a little bit of shader programming, and you don't need to worry because this will be really simple shader programming which anyone can understand without any previous knowledge. Let's start the tutorial. I have a simple scene with a floor, a table, and a few spheres on top of it. The spheres have a rigid body component attached to them, and if I play the scene, the spheres just fall down on the table. In order to make a hole in this table, we need two different mesh objects, a cylinder and a pipe. These two objects can be made directly in Unity using ProBuilder. If you don't have ProBuilder in your Unity project, simply go to Windows, Package Manager. Here select Unity Registry, scroll down to find ProBuilder, and then just click Install. Next, let's open the ProBuilder window. Go to Tools, ProBuilder, and select the ProBuilder window. I am going to dock this window right here. And now inside ProBuilder, click on New Shape, and from this window select a cylinder. After this, we can draw a cylinder in our editor simply by clicking and dragging. To improve the quality of the cylinder, we can increase the side count. I'm going to set it to 20. And again, let's create a cylinder. You can snap the size of the cylinder to grid by holding down the Control key. The next object we need is a pipe. Select pipe from the ProBuilder window. Set its side count and thickness. And now draw it in the editor. Make sure that the radius of the pipe and the cylinder are the same. Move both these objects on the table and scale them down to the size of the hole we want. And now we want to create two new shaders. One for the cylinder, which will be the hole, and the other for the table, which will draw this hole. Ideally, you want the top of your table to have a separate material than the bottom of the table. This way, the hole will only be drawn on the top of the table. So let's get started with creating a shader for the cylinder, which will be the hole. In your project, right-click, Create, Shader, and here select the unlit shader. We are going to name this shader Hole. Double-click the shader to open it up. At the top, rename the shader. And now just remove everything inside of this except the subshader heading. Next, add this line inside subshader. This code will tell Unity to draw this object after all the other normal geometry has been drawn. Next, we will add this line, color mask 0, which basically means draw nothing or an empty object over here. After this, just add these two lines, Z-right on, and the pass header. And the whole shader is now ready. Save the shader file and let's apply it on the cylinder hole. Create a new material in your project and just drag and drop the shader to apply it on the material. And now just drop this material on the cylinder to apply it. We can see that our cylinder just disappears. The cylinder object is still there, but now it's transparent. The next thing we want to do is change the shader of the table so that it does not draw behind the cylinder. This is a pretty simple thing to do. All we have to do is create a new shader for the table and set the geometry queue to higher than that of the hole. I am using the standard shader for my table. If you want to use any other kind of shader for your table, you can just find it in your project, duplicate it using Ctrl D, and then just edit it to increase the geometry queue. To create a new variation of the standard shader in my project, I will just right-click, Create, Shader, and select Standard Surface Shader. Rename this shader and double-click it to open it up. And we have a lot of code here, which is the same as that of a Unity standard shader. We don't need to change any of this, except this part here inside the tags. We want to set the geometry Q to higher than that of the whole shader. In the whole shader, we set it to geometry plus 1. So over here, let's just set it to geometry plus 2. That's all we need to change. Save the shader and go back to Unity. Apply the shader to the table material. And we can see that the part of the table that is behind the cylinder now disappears. So basically what's happening in the scene is that Unity first draws the normal geometry, which is the floor and everything else. After that, it draws the hole, which is basically nothing or an empty object. Since we have already drawn the normal geometry, it is visible behind the hole. And after we have drawn the hole, we then draw the table. And now when Unity draws the table, it sees this part of the hole which is behind the table, and it just draws the table on top of it. Next, Unity sees this part of the hole which is in front of the table, so the table is supposed to be hidden behind it. With this knowledge, Unity does not draw the table over here. Using this trick, we are able to create a fake hole on our table. Next, we want to scale the height of the cylinder hole so that it matches the thickness of the table. After that, we will do the same with the pipe, place it on the hole and scale it down to match the thickness of the table. So now that we have this hole on our table, the next thing we want to do is to make the spheres fall through the hole. We will do this by creating a script in which we will use Unity's layer collision physics to change how the spheres interact with the table. Let's start by parenting the pipe and the cylinder in a single parent object. We will call this the hole parent. And now on the cylinder, remove the mesh collider and add a sphere collider. Adjust the scale of the sphere collider and enable the isTrigger checkbox. Next, let's create a new script on this cylinder, which we will call the hole handler. Open up the script and implement the onTriggerEnter and onTriggerExit functions. Inside these functions, we are going to change the layers of the spheres. For this, create two new integer variables, one for the ID of the normal sphere layer and one for the ID of the falling sphere layer. And in the onTriggerEnter function, when the sphere enters the hole, if it's in the normal layer, we are going to move it in the falling layer. Similarly, in the onTriggerExit function, when the sphere exits the hole, if it's in the falling layer, we are going to switch it to the normal layer. Back to Unity, let's create the normal sphere and the falling sphere layers. Select any object in your project hierarchy, click on Layers, and then Add Layer. Now we need to create 3 new layers, one for the normal sphere, one for the falling sphere, and one for the table. Once we have created all these layers, select all the spheres and move them to the normal layer. Select the table object and move it to the table layer. Next, let's assign the layer IDs to the script. The normal layer is layer 9 and the falling layer is layer 10. After this, we need to edit the layer physics interactions. Open the Edit menu, Project Settings, and here select the Physics tab. At the bottom in the layer collision matrix, turn off the collisions between the table and the falling sphere. And let's run the project to test our hole. As we can see, the spheres now fall through the hole. However, there is a small issue that sometimes the spheres fall through the table after colliding with the hole. We can fix this by adding another pipe around the hole with a larger thickness. This pipe will have the default layer so that the spheres can collide with it even if they are unable to collide with the table. We can disable the mesh renderer of this pipe if we want to. And as we can see, this fixes the problem. Finally, let's just quickly add a script to the hole, which will allow us to move it using the WASD keys. The script is going to be pretty simple. We are just going to update the position of the hole based on the key pressed. And all done. Our project is now ready. We can run it and test everything out. And as we can see, we now have a dynamic hole ready for our Unity game. That's it for the tutorial. If you found this video helpful, make sure to like and subscribe for more useful Unity tutorials.